Hi, I'm Todd Cook. Welcome back to the kitchen for another episode of Polymer E-Club's Ask the Cook. We're here to talk about polymers and polymer application. We help you answer the question, what do you need to know to add polymer skills to your career? My friend and co-founder of the community here at Polymer E-Club, Dr. Paul, and I were having a conversation about polyethylene versus butadiene and noting how small differences in the structure of these molecules makes a huge difference in performance. Let's try that mental exercise together here to see what we can learn from it. Suppose we now consider just a bit of the polymer backbone, okay, 4 carbons in a row. So in the case of polyethylene, we have 4 carbons in a row. They're sharing a single bond with each other and the rest of the bonds are filled by hydrogen. The tetrahedral angle that you get from that structure is about 109 degrees. It makes this polymer very flexible. It's able to bend back on itself. That chain folding is the basis for crystallization. That's how you get the crystallinity, the higher stiffness. That's what makes polyethylene a plastic. Butadiene, by contrast, let's do the 4 carbons again. Only this time remember that butadiene has this center pair of carbons is sharing a double bond. As Dr. Paul pointed out, that does a couple of things that are really important. One is it draws those carbons closer together and it makes the relationship between them stiffer. So now some of that rotation is not there. The other thing it does is even those outer carbons, their angle is not 109 anymore, it's more like 120, right? So now even the folding takes much longer, much more of the molecule has to be involved to chain fold. So you don't get the folding. Without the folding, you don't get the crystallinity and order that you expect from polyethylene. You get something that's more random and more glassy and more rubbery depending on the temperature. All with just such a tiny change in just the bond structure and arrangement. That small change led to a huge change. We have a different material, basically a different molecular form, so we have a different molecule, we have a different product, we have a different material. That change brings this huge difference. Plus, that unsaturation, that's what the double bond is called, also makes it possible for butadiene to cross-link, and it subjects it to a susceptibility to attack by UV and oxygen, which can also break that bond and cause things to happen with the molecule that can lead to damage. That's a lot of changes with a small bond difference. So what we're saying is knowing that these tiny differences can lead to huge differences in properties and performance, that's working knowledge. Just what you get when you share with us in this community here at Polymer E-Club Ask the Cook. Now, don't forget to subscribe, like, turn on notifications, and share if you appreciate the content. You can follow a link in the description to learn more about Polymer E-Club and how to get involved. I'm Todd Cook for Polymer E-Club Ask the Cook. Thanks again for watching.